When I first heard about the Fibonacci sequence a few years back, I didn't really understand it. So, I started doing some research on the subject. The more I learned, the more awestruck I was by how universal the sequence and the golden ratio are in nature. Let's start at the beginning. The Fibonacci sequence gets its name from Leonardo Fibonacci, a man who lived in 12th century Italy. Fibonacci wanted to calculate how fast rabbits breed in nature. He generated the series assuming that each pair of rabbits would produce another pair as soon as they matured at 1 month. Over 12 months, assuming none of the rabbits die, the rabbit pair expansion would look like this. When written as a number sequence, voila, we get the Fibonacci sequence. Soon, mathematicians around the world discovered that this was a very unique sequence of numbers. They took each number in the series and divided it by the previous number, generating a whole new series of numbers. This new series was even more fascinating than the original one. As the series goes on, the ratio approaches the value 1.618, getting increasingly accurate but never quite reaching the ratio. This ratio, 1.618, was called the golden ratio, the golden mean, or the divine proportion, as it seems to be omnipresent everywhere in the universe. This golden ratio is also called phi and is represented by this symbol. Now, what do I mean by all this? Let's take a look at some examples. First, we'll observe some examples with the Fibonacci sequence itself. Flower petals. The number of petals on most flowers is a number in the Fibonacci sequence. For example, lilies and irises have 3 petals, buttercups have 5, some delphiniums have 8, and daisies can have 34, 55, or even 89 petals. Tree branches. Most trees express the Fibonacci sequence in their growth points, the places where new tree branches form or split. One trunk grows until it produces a branch, resulting in 2 growth points. The main trunk then produces another branch, resulting in 3 growth points. Then, the trunk and the first branch produce 2 more growth points, bringing the total to 5. This pattern continues, following the Fibonacci sequence. Seed heads of flowers. If we look closely at the array of seeds in the center of a sunflower, we can see 2 sets of spirals, one curving left and the other curving right. Amazingly, if we count these spirals, the 2 sets are found to be 2 consecutive Fibonacci numbers. The same is true for pine cones, pineapples, and cauliflower heads. But why do these arrangements occur? Do plants know about the Fibonacci series and the golden ratio? No. Following phi is what gives the ideal arrangement that maximizes space and gives the best possible exposure to sunlight at all levels. It is simply the most efficient arrangement. Coming to the golden ratio, its presence everywhere in nature, art, and architecture is truly astounding. Here are some examples. Animal bodies. For an average human, the ratio of measurement from the navel to the floor and the top of the head to the navel is the golden ratio. Similar patterns are also observed in dolphins, penguins, and insects. Fingers. The length of each section of our fingers, from the tip to the base of the wrist, is larger than the preceding one by approximately a ratio of phi. DNA molecules. Each full cycle of the double helix spiral of the DNA molecule measures 34 angstroms in length and 21 angstroms in width. These are consecutive Fibonacci numbers and therefore have a ratio of approximately 1.618. Art and architecture. Without mathematics, there is no art, said artist Luca Pacioli, and how very right he was. Some of the greatest artists the world has known in the past few centuries, like Da Vinci and Michelangelo, used the golden ratio to enhance visual harmony in their timeless creations. The Egyptians built the pyramids based on phi, as did the Greeks when they built the Parthenon, and the Indians when they constructed the Taj Mahal. Architects today continue to use this ratio to improve aesthetics in many modern structures. Now, let's see how to construct the golden rectangle. First, we draw two squares with side lengths of 1 unit each, side by side. Then, we make a 2 by 2 square, adjacent to these two squares. We then continue this pattern, making sure that each square has an edge that is the sum of the two squares before it, just like in the Fibonacci sequence. Now, using a compass, we can make an arc in each of these squares with a radius equal to the side of the square. What results is called the logarithmic spiral. The nautilus shell, animal horns, hurricanes, and even our Milky Way galaxy display the logarithmic spiral. Earlier, we saw that our fingers were proportioned per the golden ratio. This allows us to form a perfect logarithmic spiral when we clench our fist. Isn't all of this simply amazing? Math isn't just cool, it's super cool. Thank you and Happy New Year to all.